That's fine. Okay, here is today's class. We're going to look at some homework problems that were sent in, and we'll go from there. What? You hadn't done it. Why not? Well, is it posted? Is it up on? Okay. Well, it shouldn't have an ending date on it, but you need to get it done probably before Thursday, because Thursday or Wednesday, we got to go over the last section, which is I think 11.1 or 10.1. Huh? Yeah, 10.1. 10.1. I got to go over that last, so we still got another lesson to go over. All right, 17, 21, 49, 63. Here's the first one. 5.6, 17/10. When I say 17/10, that means 17 in the book. If you turn to 5.6 homework in the book, number 17, it'll look like number 17. It won't be exactly like number 17, but it'll look like number 17 in the book. And the 10 right here, see that 10? That's online question number 10. So if you printed out your homework on 5.6 and you look at the 10th problem or question number 10, it'll look like this problem we're fixing to pull up. What about? This question is one of those questions. I think I went over it the other day. And I remember telling y'all that the -6, when it's squared, and the -6 quantity squared is two different animals. Yes. Now, you also got another exponential rule here. What's the other exponential rule? A negative exponent. What do you do with a negative exponent when you don't want a negative exponent? So, you got two rules here. A is -6, -2. Well, the first thing you need to realize is any whole number is over what? 1. That -2 is not a good thing. So flip it. That's the inverse rule. So we're going to use the inverse rule. And the inverse rule says if you have a negative exponent, you flip it, and it becomes positive. So that'd be 1 over -6 to the second power. 1 over negative, and then the 6 is raised to the second power because the 6 is the only thing that the power is attached to. Everybody understand that? Because it doesn't have parentheses around it. So your final answer is -1 over 36 or 1 over -36. Either one of those. Now B is -6 quantity squared. Now, if you want to put this in any kind of comparison, this is a cat, this is a tiger. All right? They both have tails. They both look like a cat, except one's bigger than the other. They both have 4 paws. They're both good with balance. They both have teeth structure. One's bigger. But as far as saying that the animals are identical, they're not. But they are similar. But they do different things. If you have a house cat run at you and headbutt you, running right through you like a bull, it's not going to do anything. But you got a 600 or 800 pound tiger running towards you and hit you, what's going to happen? He's going to run over you. So they're not the same thing. All right. So this one says I'm going to take -2. Because that's a negative. I'm going to turn it upside down because it's over 1. Flip it by the inverse rule. And that's going to give us 1 over -6 quantity squared. Now, since this 2 is on the outside of the parentheses, and since this problem does have parentheses from the beginning, this whole thing is raised to the second power, the negative and the 6. So therefore, you've got this. I'm going to put an extra step in here. 1 over negative 6 times what? Negative 6, which is 1 over positive 36. Now see, the difference between these two is right here. You don't have this right here. You've got this. Put a little space in here. Here you've got 1 over negative parentheses 6 times what? 6. That's the difference between the two. The difference between the two, I'll take my handy dandy green highlighter, is right here. And then down here, that's the difference between the two. Now, even though that's probably not a test question on my test, there's a lot of standardized tests that put this type of question on there. So you might want to make a note of it, because if you ever take another placement test, or if you take an employment test, say like at Michelin or Bosch, that type of question will be on there. Huh? I don't know, what's a work key? What is that? Yeah.
It's like it's a test.
Yeah.
Oh, there's 3 different. Yeah, I need to.
That's why I offer the little refreshers online when they teach it online, because a lot of students come up here and the first thing they say is, I'm applying for a job and I ain't had math in 500 years. Right? 500?
Well, no, I passed that.
150. All right. So there's your answer. Make a note of this. Parentheses, no parentheses. If it doesn't have parentheses, then that's 6 to the second power with a negative out front. And of course, that's a negative too, so you got to throw it upside down. Okay? Let's check our answers since we make sure we know what we're doing. Yeah. Okay. So negative. It's probably want the negative out front, but I'm going to put it 1 over 36. It probably won't like that. So I'll put the negative on the bottom. See if it likes that. What do you mean?
There's a line on top of the line. I struggle a lot because they tell you, even though your answer is correct, I get aggravated at it.
All right, let's look at the next problem sent to us. Next problem, 21 in the book, number 12 online. All right, y'all try that one. I left my drink in the truck. Gosh, it's hard for me. That's why I need to have a drink in my master's truck. No, that's all right. After y'all leave. I heard that the Russians hacked the Super Bowl and took it away from Atlanta. Said that Atlanta was winning and was supposed to win, and the Russians hacked the Super Bowl. Yeah. Took it away from. Damn
There's a lot of
Russians.
money on the line on that one. We'll keep that. That's what I believe.
I think it's interesting that we just had a Super Bowl won by the ones that wasn't supposed to win, as we had a presidential election won by the one that wasn't supposed to win, and the person that wins, the people that run, and the winners of the Super Bowl were named the Patriots. I think that's interesting. All right, here we go. Now, you can do this one 5 or 6 different ways. 5 to the 5th times 5 to the negative 4th. Now, what are these? These are the same what? The same bases. They're called bases because these are exponents. These are the same bases. So what does that mean we can do with the exponents if we're multiplying them? Add them. You have $5, you owe $4. What's the outcome? And 5 to the 1 is? Another way of doing it. 5 to the 5th over 1 times 5 to the 4th, negative 4th over 1. What rule can we use here to get rid of that negative 4? Inverse rule. So that'd be 5 to the 5th over 1 times 1 over 5 to the 4th. And that's 5 to the 5th over 5 to the 4th. What can we use here? Quotient rule. The quotient rule says that if you have the same basis, what can you do with the exponents when you divide? 5 minus 4, which is equal to 5 to the 1st, which is equal to 5. Another way, take this and draw it out the old-fashioned way. 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5 times 5. And then what happens? And you're left with. So there's 3 ways you can do this problem. Well, the first problem, A. Now you do the second. And try to do it 3 different ways. Because you can do it 3 different ways also. Or you can just sit there and say that you're what? A failure.
My son actually helped me.
Good.
Because I couldn't figure out, I couldn't remember how to borrow the money. When subtracting from the guys, how much grew over some dollars was for it.
I'm glad to help you. They're organizing a protest in Williamston. Protest today at 5 p.m. in front of Williamston Town Hall because time to riot and protest in the streets because they don't believe that New England won the Super Bowl. We're being sarcastic.
Well, I mean, he's never won one of these days.
But Atlanta won the popular vote.
I'm glad to see old George Seaton out there.
Yeah, I didn't watch it until the NFL takes a stand on the pledge and not the pledge, but the flag, I'm not going to watch it.
I didn't watch it.
You don't take advantage of the freedom of America and not stand up for it. I'm sorry. You make millions of dollars the American way, capitalistic way, and you don't want to, I've got a problem with that. Now, if you got a religious thing, like, which religion they don't say pledge allegiance. Which one is it? Yes. I'm not talking about that. I'm not talking about religion. I'm talking about you making money and millions and millions and millions of dollars under the freedom of the United States flag, but you can't sit there and stand up and at least be attentive. That's bullcrap. That's bullcrap. I'm sorry.
I was shocked to see when I went to the races how many men were not even taking.
Well, that's because they sorry and no count. I'm sorry. I fought for that flag, and I will fight for that flag. I just think I'm used for these people that say, yeah, I got whippings when I was a kid, but that still don't make me, I still don't represent my flag. I mean, I could pick out anything to, don't even get me started. Shut up, you. I see you get out of the city vehicle. You work at the city. You work at the city. I thought I saw you get out of the city vehicle. I got friends that work at the city. That's why I was asking. Okay. Where do they work? Oh, okay. I don't know that. Was there, most of my people I know work at City Hall, and, stuff like that. County council, city council.
I thought it was really cool. I saw something about in November Falcons Day with the names of fallen soldiers on the helmets.
I didn't know that.
Yeah. I'll send you the link to it. It's a really cool video.
Well, what was it when the guy wanted to wear something with the law enforcement officers on him and they wouldn't let him do it?
Yeah, it was big
That, I don't understand that either.
Wasn't it on his tennis shoes or?
I don't understand that. I really don't. I think our country's lost its way. I really do. 3 to the negative second times 3 to the negative 2. Oops. Oh, they're both the same. Okay. All right. The first way we can do it is to add them. 3 to the what? Negative 2 plus what? Which is 3 to the what? Which is over 1, which 1 over 3 to the what? Which is 1 over 81, I thought. Okay, that's one way to do it. Another way to do it, 1 over 3 to the second times 1 over 3 to the second is equal to 1 over 3 to the 2 plus 2, which is equal to 1 over 3 to the 4th, which is equal to 1 over 81. Is there another way to do it? Yes, there's another way to do it, and that is to 1 over 3 times 3 times 1 over, this is what you were talking about, and that's 1 over 3 to the 4th, which is 1 over 81. One thing you'll learn about the exponential laws is there's no certain way to do it. You can do them many different ways. Will you come out with the same answer? Yes. Okay, so that's that one. So far, these are all possible test questions. Because a lot of your questions are going to come from 5.3 and 5.6. 80% of your test questions are going to come from 5.3 and 5.6. Next question, 49 in the book, 26 online. Test question. That's 6 zeros and 4 zeros. This is a test question.
When I sent it to you,
Mhm.
I didn't read the calculation completely, and I said, I did.
That's good.
I didn't think
Well, I wouldn't want it like, is that the way they wanted it?
well, that's what I,
Oh, okay.
yeah.
All right, I want you to write it down, and I want you to try it. All right. So the first one is 2.0 times 10 to the 6th power. And the second one is 2.3 times 10 to the what? 5th power? 2.0 times 2.3 times 10 to the 6th times 10 to the 5th. Now, of course, this, you shouldn't have to. 2 times 2.3 is 4.6. But this one, same what?
Same thing.
Same base. So what do you do to the exponents? Plus 5, so your answer is going to be 4.6 times 10 to the 11th power. So you just now calculated in your heads 2 million times 230,000 is 4.6 billion. Let's see, 3 will go into 11 3 times. So we want to say it's 46 trillion, something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1,000 million billion. 460 billion. That's all. That is a good test question. You'll see a lot of those on the test. Next question. 5.663 is 34, so it's like number 34 in your homework. Number 63 in the book. Any word problems having to do with scientific notation is a very high possibility test question, especially anything to do with science. In June 2010, the population of a large country was blah, blah, blah. The population of the world, blah, blah, blah. Determine the ratio of the country's population to the world population by dividing blah, 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 blah. Well, it tells you what to do. It says divide what? Dividing the country's population by the world's population. Well, one thing you'll always know about percentages is the biggest number is always on the what? Bottom. Always. So, let's put this in. So we got population of large country was 307, and then what? That's what that means, okay? And then we divide it by, you don't have to do it that way. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? So that's going to be 3.07 times 10 to the 8 divided by 6.94. So that's 6 and then 9, 4, what? What 3? What?
307.
Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. Check that for me. That's supposed to be 6.9 billion. So 6.94. Ten to the what? 9. 6, 7, 8, 9. So now you can take the calculator out and divide 3 divided by 7. Or 3.073 divided by 6.94. Somebody do that for me.
About 600.
Divide 3.073 divided by 6.94.
795.
0.4279. 0.442?
Yes.
0.442.
795.
That's good. Okay. Times 10. And then 8 minus what? 9. So 0.442795 times 10 to the negative 1. 4.42795 times 10 to the negative 1, 1. Which way did I move this decimal in my head to get it back the way it was? To the left. So 4.42795 times 10 to the negative 2. 12.04 is what I got. They say write it in scientific notation or oh, whatever. 0.044. I'm sorry, I just wrote 0.04. It's supposed to be 0.044. They kept on with the stuff. With this stuff.
They aggravated me with the way they killed me in some way.
Yeah, that's fine. I moved it here and I just wrote 0.04. I didn't write 0.044. Okay. And if you have a question like that on a test and you show me your work, then we'll fix it. Ain't no big deal. Only time I stand beside something marked wrong is if directions supersede or if you just got the problem wrong. All right. Now, if I see that there's some kind of you know, chance, then I'll let you, I usually let you have it. But you gotta, it's your responsibility to show me, okay? That way you get, when you get in these other science classes and you check your, go over your, that way you can challenge in your other classes and be comfortable with challenging. Because that's, you're gonna have to do it one day. All right. And that's all the questions I've got for homework right now. Let me delete these so I don't have it in that folder anymore. All right, let's look at 10.1. 10.1 is not that big of a deal. And you see, is it 10.1 or 11.1? Probably fractions, decimals, and percents. I'm not going to spend a lot of time on it. I'm going to let y'all read over it, and then we'll go over it Wednesday. But go ahead and, if you got a book, turn to 10.1. I think I changed y'all's homework. I think I gave y'all another 5.6 with more problems in it. Yeah, that's what this one is, and I'm not going to go into this until Wednesday because you need to spend as much time as you can on scientific notation because that's what's going to get you on the test, the scientific notation. So let me turn back, and we'll go over that Wednesday. We'll go over chapter 10 Wednesday. Let me show you again what I would worry about if I was you. Chapter contents 5, 6, study plan. That, one like that one. Or we did one like that one. One like that one. One like that one. One like that one. All these last 10. I'm looking for the, where's the word problems?
I know it was that last row of questions on the homework that I was looking at.
Well, buddy, I didn't even see them. I started from right here. I don't see any word problems. No, let me look on the homework.
Yes.
Yeah, there's one. There they are. Large waterfall. But usually, when you do one like this, you need to think, okay, let's drop all the big numbers. The distance from a planet to its moon is approximately 257, blah, 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 blah. How many hours would it take to, okay, the distance from Anderson to Spartanburg is 70 miles. It takes you, your car goes 70 miles an hour. How long does it take you to get to Spartanburg? All right. But what if I tell you this? What if I say you're going 50 miles an hour? Remember, distance equals rate times time. Write that down. Distance equals rate times time. It's one of the most important formulas for you ever to remember. If you don't know how to do anything, remember how to do distance equals rate times time. Why? Where is my whiteboard? Oh. Okay, I guess it just disappeared. Yep, it sure did. It just disappeared. Pull it back up. Yeah, thank you for coming back. This is one of those formulas that even if you don't learn anything out of my class, at least learn this. Because this applies in real life. Distance equals rate, which is the speed, times time. So distance equals rate times time. Time is equal to rate divided by the distance. Rate is equal by the time divided by the distance. So with this one formula, you have two other formulas that can be solved for. So which one is, what are you given here? What is this? That's the distance. What is this? So if you have the distance and the rate, which formula are you going to use? The second one. T is equal to 20,000 divided by 257,000. I'm sorry, D divided by R. It's supposed to be D divided by R. The reason I knew that is because it's giving us a small number. Anytime you're in space, you're going to be traveling like the years on fire. So that's 257,000 divided by 20,000. Now from the start, what can you do? Knock off the three what? Knock off the 3 zeros, but you're still going to have to use scientific notation. T is equal to 2.57 times 10 to the second, over 2.0 times 10 to the first. Well, 2.57 divided by 2 is 1.285 times, what's 2 minus 1? 10 to the 1, so that means 1 to the right, so that means 12.85 whatever units, or 13, what does it say, in the hours, miles per hour. So it would take 13 hours to travel from planet to its moon. These type problems will automatically be on the test, because the only reason you're learning scientific notation is for science, any kind of science application. And that distance equals rate times time, you use it if you're traveling, you use it if you get a speeding ticket. That's how they basically give you a speeding ticket. The radar hits your the thing you're driving. There, thank you. Hit your car a series of 5 or 6 times when they shoot it at you. All right? That distance that ray hits your car shortens the closer you get to the radar gun. So that distance is closing like this. So they take that distance equals rate times time. They know the time it takes for light to travel, which is of some god-awful number, and they take that and divide it and tell you how fast you're going. So that's used with your radar gun. It's used in an accident. What do they measure in an accident? Of what? I know, but what do they measure if you stomped on your brakes? What do they measure? Your skid marks. And they use distance equals rate times time. One of the most applicable, next to some of your area and perimeters, that's one of the most used formulas in the real world. Okay? All right, we're gonna stop it there because I'm gonna give y'all some more chances to work on your homework because I'm giving you the rest of the afternoon and today and tomorrow to get 5.1, 5.2, 5.3, and 5.6 finished. All right, so that means I'm not gonna give any of y'all, I need extra time. No, you don't. You need to get it done.